Welcome once again, and today we are working out a trigonometric equation, and we shall get the values of theta between 0 degrees to 180 degrees as indicated over here. And let's begin. Now we have 2 cos 2 cos 2 theta plus 7 sine theta equals 5. Now what we need to do at this point here, we need to express cos 2 theta in terms of sine theta. And how do we do that? Cos 2 theta is an example of a compound angle, not compound angle actually, but this is a double angle, and we are going to use the formula for double angle formula. And before we go there, let's remind ourselves of the compound angle formula for cosine A plus B, which states that this one equals to cos A cos B minus sine A sine B. Now if we let B equals to A, then what we shall have here is cos A plus A, and A plus A we know is 2A. So what we shall have is cos 2A equals to, since B is A, we shall have cos B and cos A, and cos A is the same as multiplying the 2, and that becomes cos squared A minus sine squared A. Now this is an example of a double angle derived from the compound angle formula. So it means that cos 2 theta equals cos squared theta minus sine squared theta. Right? Now I want to write it in another way, because here I still see cos squared theta. So if we can remember the trigonometric identity, which states that if you have cos squared theta plus sine squared theta, this one equals to 1. This one will help us here, because from here you find that cos squared theta equals 1 minus sine squared theta, and if I substitute this one in this equation, then it means that cos 2 theta equals to, where there's cos squared theta, you put 1 minus sine squared theta, and this one you subtract sine squared theta. Okay, now, so what does it mean? It means that cos 2 theta equals to, if you open the brackets here, you shall have 1 minus, so you have minus sine squared theta minus sine squared theta is the same as minus 2 sine squared theta. Those are just two like terms being added together to give us that value. All right. Now, so it means cos 2 theta here is given by that equation. Now, coming back to our original equation here, we shall have 2 cos 2 theta. So instead of 2 cos 2 theta, I shall put in 1 minus 2 sine squared theta, and I shall have 2 into 1 minus 2 sine squared theta plus 7 sine theta equals to 5. Let's open the brackets. We shall have 2 minus 2 times 2 here is 4 sine squared theta plus 7 sine theta equals 5. Now from here, I don't want to work with sine theta because it will make it a bit complicated for me to get the values of theta yet. So I'm going to let sine theta equals to a letter like y, so that where there is sine theta you put y, and I shall have 2 minus 4 y squared because of the sine squared theta plus 7y equals to 5. Right, and I can rearrange this in this form so that I can collect like terms. First of all, 2 crosses the cosine, I shall have minus 4y squared plus 7y equals 5 minus 2, and dividing both sides, dividing everything by negative 4, what I shall have is y squared minus 7 over 4y equals to negative 3 over 4. So this is also an example of a quadratic equation, and since it doesn't seem to be a perfect square, because if I write it in form of ax squared plus bx plus c equals 0, I shall have y squared minus 7 over 4. Let me get some more space. So 7 over 4y, and then plus 3 over 4 equals to 0. So when I look at this, we don't have a perfect square, but now we can use the formula for completing the square method to get the value of the values of y. Now, just to get some little more space, I shall wipe off this area. Now let's proceed to use the formula for completing the square method, and for me to do that, I shall put y squared minus 7 over 4y equals to negative 3 over 4. Now, to make my my left hand side of the equal, to make it a perfect square, I shall take half the coefficient of y, square it, and then add to both sides of the equal, and what I shall have is y squared minus 7 over 4y plus negative 7 over 8, because half of negative 7 over 4 is negative 7 over 8 squared is equals to negative 3 over 4. You also add negative 7 over 8 squared. Now, in this case, now I'm having a perfect square of 1 minus 7 over 8 everything squared, and this one equals to what I have on my right hand side is you take negative 3 over 4, add to 49 over 64, and that one simplifies to 1 over 64, and this one equals to y minus 7 over 8 everything squared, so that y minus 7 over 8, if I raised everything to power half, that means getting the square root on both sides, then it means that the value here 7 over 8 equals to 1 over 8, and since we were getting the square root, this one is either plus or minus, so that the values of y become plus or minus 1 over 8 plus 7 over 8. So the first value of y is, you take plus 1 over 8 plus 7 over 8, you shall get 1. Or you take negative 1 over 8 plus 7 over 8, it will give you the value of 3 over 4. All right, let's proceed now to get the values of theta, just to get some more space over here. But since we said we assumed that remember earlier on we assumed that let sine theta equals to y, so it means that sine theta equals 3 over 4 or 1. All right, now the question restricted us to get the values of theta ranging from 0 degrees to 180 degrees. And if I can just sketch my quadrants, remember sine is positive in the first and the second quadrants. This one shall help us to get the values of theta, starting from sine theta equals 3 over 4. It means that theta is the sine inverse of 3 over 4, and this gives you the value of 48.59 degrees. So it means the first value of theta is this one here, 48.59 degrees. Now also, since sine is positive in the second quadrant, then it means the other value is this one here. The other value of theta is this one, which is the same as 180. You subtract 48.59. So you take 180 minus 48.59, you shall get a value of 131.41 degrees. All right, so those are the values of theta ranging from 0 to 180 degrees. But also don't forget that sine theta is also equal to 1. So if sine theta is 1, then it means that theta is sine inverse of 1, which is 90 degrees. So it means that the other value of theta is 90 degrees. And since in the first and our second quadrants the values are still the same, so we shall just pick one value, which is 90 degrees. So it means that the values of theta are, the first value is 48.59 degrees, the other one is 90 degrees, and then followed by 131.41 degrees. So those are the values of theta ranging from 0 to 180 degrees. Thank you everyone for watching. If you like the video, please give it a thumbs up, show some love by subscribing to the channel, and until next time, may God bless you for now.